Welcome to this video. In the previous video, we learned about the area of an equilateral triangle. In this video, we will study the outcome of dropping a perpendicular to the hypotenuse of a right-angled triangle. Can you tell me, out of these triangles, which triangle is a right-angled triangle? Absolutely correct. Triangle ABC is a right-angled triangle. If we drop a perpendicular to the hypotenuse BC from the right angle of the triangle which intersects the hypotenuse BC at point D, then how many triangles can you see in this triangle? Absolutely correct. Here we get three triangles: triangle ABC, triangle ABD, and triangle ADC. We can see that all of these three triangles are right-angled triangles. Can you tell why? Because AD is perpendicular to the side BC, and we know that perpendiculars intersect each other at 90 degrees, which is why triangle ABD and triangle ADC are also right-angled. What else do you see in these triangles? Let's rotate the triangle ABC in such a way to observe and understand the triangles. If you consider the measurement of angle BCA as x in the triangle ABC, can you tell me what angle ABC will measure? You must remember that the sum of the measurement of all the angles of a triangle is 180 degrees. Therefore, the measure of the angle ABC will be 90 minus x. Similarly, the measurement of angle CAD in triangle ADC will also be 90 minus x. Similarly, can you tell the measurement of angle DAB in triangle ABD? Well done. The measurement of angle DAB will be x. Can we make any more observations of these triangles? For this, we focus on triangles ABC and ABD. You will see that angles ABC and DBA and angles BCA and BAD are equal. Hence, based on AA criteria, triangle CAB and triangle ADB will be similar triangles. Similarly, you can check the similarity of triangles CAB and ADC and triangles BTA and ADC. In this video, we learned that if a perpendicular is dropped on the hypotenuse from the right-angled vertex of a right-angled triangle, then the triangles on either side of this perpendicular are similar to each other. Welcome to this video. In the previous video, we learned that if a perpendicular is dropped from the right angle to the hypotenuse of a right-angled triangle, then the triangles thus formed are similar. Today, we will understand Pythagoras Theorem with its help. Can you tell from the previous class what is Pythagoras Theorem? Absolutely correct. According to the Pythagoras Theorem, in a right-angled triangle, the square of the hypotenuse is equal to the sum of squares of the remaining two sides. Can you tell why? To understand this, we rotate our right-angled triangle in this way. And then, from the right angle, we drop a perpendicular to the hypotenuse. As you know in the previous video, if a perpendicular is dropped at the hypotenuse from the right-angled vertex of a right triangle, then the triangles on either side of this perpendicular are similar to the full right-angled triangle and also mutually similar. From equation 1, we know the triangle ABC and triangle BDC are similar. Hence, side BC and side DC and also side CA and side CB will be mutually proportional. By cross-multiplying, we get DC times AC is equal to BC square, which we can show from equation 4. Similarly, with the help of equation 2, we get AC times AD equal to AB square, which we can show from equation 5. Now if you add equation 4 and 5, we get DC times AC plus AC times AD equals BC square plus AB square. You can see that we get a common factor AC here, which we can write like this. Now if we add sides DC and AD, we get side AC. On further solving, we get AC square equal to BC square plus AB square, where AC is hypotenuse of triangle ABC and also AB and BC are the remaining two sides of triangle. Thus, we can say that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides, which proves the Pythagoras theorem. In this video, we learnt the proof of Pythagoras theorem with the help of similar triangles. In the next video, we will see interesting examples based on the Pythagoras theorem. Welcome to yet another video. In the previous video, we understood the proof of Pythagoras theorem with the help of similar triangles. Today, we will see an example based on this. Angle N is a right angle in the right-angled triangle MNP, in which MR and PS are medians drawn from the vertices M and P respectively. If MP is equal to 5 centimeters and MR is equal to 3 root of 5 by 2 centimeters, then find the length of PS. Pause the video to solve the question and match your answer later. Can you tell me how you can solve the question? Absolutely correct. First of all, we will draw a figure based on the information given in the question. So let's draw. From the question, we know that the triangle is a right-angled triangle, so we draw a right-angled triangle, in which angle N is the right angle. Now from the points M and P, draw the medians MR and PS on their opposite sides NP and MN respectively, which divide the sides NP and MN respectively into two equal parts. Also, we know the measurements of the sides MP and MR, because triangle MNP is right-angled at N. So, from the Pythagoras theorem, we can say that square of MP will be equal to the square of MN plus square of NP, denoted by equation 1. Similarly, in right-angled triangle MNR, square of MR will be equal to the square of MN plus square of NR. We know that NR and RP are two equal parts of NP. Hence, NR equals NP by 2. On further solving, we get equation 2. Similarly, we get equation 3 from right-angled triangle NPS. By adding equations 2 and 3, we get this equation. Here, from equation 1, Mn square plus Np square can be replaced by the square of Mp. Can you tell us what we should do next? Well done. Now, we will replace the values of Mr and Mp in this equation. We get PS square equal to 20. Taking square root of both sides, PS equals positive and negative 2 square root of 5. PS is the median of the triangle MNP, whose length we have to find. Can the length be negative? Absolutely correct. Length cannot be negative. So, we will consider positive. So, the length of PS will be 2 square root of 5 centimeters. Hope that now you've understood the Pythagoras theorem well.